Good afternoon, everyone. This afternoon, I'm going to present to you this article titled "Energy Digestibility and Concentration of Nitrogen-Corrected Apparent Metabolizable Energy of Azolla and Duckweed in Broilers." The flow of our discussion will start with the introduction, the objectives, and then the materials and methods, including the animal and experimental design, experimental diet, feeding and excreta collection, chemical analysis, energy calculation, digestibility calculation, statistical analysis, and then we'll proceed to the result and discussion, conclusion, and then lastly, the acknowledgement. So the energy represents the greatest proportion of feed cost. Therefore, it is a must to identify and measure the inherent energy concentration of a feedstuff as a basis in feed formulation. Protein, carbohydrates, and fats digested and absorbed will yield energy that is used in the normal functioning of the animal's body. Currently, apparent metabolizable energy, or the AME, uncorrected to zero nitrogen, or AMEN, is the most practical system used in estimating energy of an ingredient and or diets, and are presumed to be additive in the mixed diet in poultry. As proven by various published reports, adult birds make use energy from feedstuff efficiently than growing broilers. Different breeds and age may obtain different energy values due to physiological differences in their digestion and absorption of nutrients. AME values depend on the nutritional composition and form of the test diet. Example, high-fat ingredients are usually underestimated, while high-protein feedstuffs are generally overestimated in the AME system compared to carbohydrates, because fats are highly digestible, while protein have higher heat increment produced during ingestion, digestion, absorption, and metabolism. Azolla and Duckweed were both unconventional feed ingredients. However, because of the shortages of supply and fluctuating prices of conventional feed ingredients, this motivates local producers and researchers alike in finding alternative feed ingredients that will replace totally, or at least in part, the conventional feed sources. There were published studies of these two ingredients that focus more on nutritional composition, antioxidant properties, economics of production, but less on digestibility of nutrients, specifically on energy, that will evaluate and measures the energy concentration of these two ingredients. Hence, this study. The objective of the study is to evaluate and measure the energy concentration of Azolla and Duckweed in broiler, specifically to get the percent dry matter, the gross energy in kilocalories per kilogram, the apparent metabolizable energy, and the apparent metabolizable energy nitrogen corrected. In materials and methods, 24 heads for 10 days old broiler chickens were used, placed individually inside metabolic cage and randomly allocated to 3 dietary treatment using RCBD, and blocking factor was individual initial weight of birds. 3 dietary treatments were prepared: the basal diet, then the basal plus 20% Azolla, and basal diet plus 20% duckweed. The experimental diet, basal diet, or the corn soy diet, were composed of corn, soybean meal, monocalcium phosphate, limestone, L-lysines, methionine, vitamin and mineral premix, and salt. While the Azolla and Duckweed treatments diet were prepared by substituting 20% of the basal diet. Feeding and excreta collection. Chick booster ration from day 1 to 13 days were the common diet. On day 14, birds were weighed and transferred to individual metabolic cage, and dietary treatments were given gradually from 65 to 130 grams up to the 19th day as an adaptation period, and weigh again on the 20th day after fasting for 4 hours. This to ensure that all the feeds eaten by the birds from the previous day were totally excreted. After weighing, birds were returned to their cage and dietary treatment at 130 grams per day divided by 3 meals for 3 days from day 20 to day 23. Every morning, collection of excreta was done for 3 consecutive days. Excreta were cleaned by removing feeders, scales, feeds, and other contaminants before storing it to the freezer per treatment. And on the last day, the birds were fasted for 8 hours from 12 midnight to 8 in the morning and weighed to determine the final weight. On chemical analysis, excreta samples were pulled per bird and dried in a coarse air oven and finally ground. Excreta, diet, ingredients. Samples were analyzed in triplicate for gross energy using bomb calorimetry and proximate composition following the procedure of EOAC 2007. On energy calculation, DE and ME in the basal diet were multiplied by 80% to calculate the contribution from the basal diet to the DE and ME in diets containing each feedstuff. DE and the apparent metabolizable energy and corrected in duckweed and azolla were calculated by difference using the equation by Widmer et al. In 2007. The DE with subscript D is the digestible energy of the diet in kilocalories per kilogram, while the DE with subscript B is the digestible energy of ingredients in kilocalories per kilogram. The S over B is contribution level of the diet in the percent, while S with subscript A is contribution level of component from test ingredients in percent. Digestibility calculation, apparent total tract digestibility or percent ATTD of dry matter and the gross energy. In this formula, the nutrient I is the total nutrient intake, while the nutrient F is the total fecal output, following the formula of Almeida and Stein in 2010. Statistical analysis. Mixed procedure of SAS was used for bird as the experimental unit, diet as the fixed effect, and replicate as the random effect. Least square means was calculated for each independent variable, and when diet was significant source of variations, PDIP option of SAS was used with alpha level for significance was 0.05 and tendencies was 0.10 respectively. On resultant discussion, daily energy balance of broiler chicks fed with corn soy or the basal diets and diets with 20% duckweed and 20% azolla revealed that gross energy intake in kilocalories per kilogram tended to decrease on diets with 20% azolla, but significantly deeper to the diets with 20% duckweed. This might be due to higher fiber content of duckweed that will cause enlargement of the crab, leading to a gut feel sensation, thus decreasing gross energy intake. The decreased energy intake of birds fed with 20% duckweed and 20% azolla resulted to a highly significant decline of body weight gain. And the significant decline of body weight gain resulted also to a highly significant decrease in nitrogen or N gain and the GA of N gain in kilocalories per kilogram. The apparent metabolizable energy of the diet showed a significant decrease of the diet with 20% duckweed compared to basal diet and with 20% azolla. But when the diets were corrected with nitrogen, showed the same result with EME of the diet. When the two ingredients were compared on AMA and AMA corrected with nitrogen as feed or as dry matter basis, azolla was significantly higher than the duckweed, despite inferior to soybean meal and azolla on gross energy, apparent metabolizable energy, and apparent metabolizable energy and corrected. Duckweed have similar values on body weight gain, in gain, and gross energy for in gain compared to azolla. And this might mean that duckweed have higher digestibility compared to azolla. In conclusion, there were a lot of factors that affect digestibility of nutrients previously reported, and this includes the type of animal, the age, inherent nutritional composition of ingredient, among others. In the current study, duckweed had inferior digestibility coefficient on gross energy, apparent metabolizable energy, and corrected, resulting to poor growth performance, thus decreasing the in gain and gross energy for in gain compared to soybean meal. In addition, azolla have better gross energy, apparent metabolizable energy, and apparent metabolizable energy and corrected, but similar values on body weight gain, in gain, and gross energy for in gain compared to duckweed. The poor digestibility might be due to higher fiber content of duckweed. Therefore, Azolla may be used as an alternative feed ingredients for broiler at lower level of inclusion, while duckweed results need further studies for validation. The authors would like to thank the personnel of the University Farm of the University of the Philippines, Los Baños, for providing the building where the experiment was set up and all the equipment needed and helping us in the conduct of the study. To Sir Gary Umali in memoriam for helping and guiding us in the chemical analysis of the samples. Ma'am Eden Sarmiento for her guidance during the conduct of chemical analysis, and Dr. Florinia Imerca for her invaluable contribution in the analysis and interpretation of the results. All authors equally contributed to the works described in this article. With that, thank you very much. Thank you for listening.